So an array is like a row of small lockers, except that you can't cram lots of stuff into it. You can only store one value at each locker. So here's a row of lockers if you've never seen what they look like before. I know many of you don't use your lockers, so maybe it's informative. Not that there's anything wrong with not using your lockers. I just worry about your back sometimes when I see the backpacks there. You can store a value in an array using an index, a location in the array. An array index is like a locker number. It helps you find a particular place to store your stuff and retrieve stuff. You can get or store a value from or to an array using an index. Arrays and lists in most programming languages start counting elements from the number 0, so the first element in an array is at index 0. This is similar to how strings are indexed in Java. The first character is at index 0. So if you remember back to strings, if you had a character, or excuse me, a string that was like this, the index numbers went 0, 1, 2, 3, 4, 5, so on and so forth. And then there was also a length that told you how long the string was too, but you could access individual elements of the string by thinking about where they're indexed at. I've got a note sheet here for you that I put together, and I thought we could maybe take some notes about arrays before we kind of think of our own ideas on arrays here. Did these come around properly? Okay, good. So what is an array? A data structure that contains a sequence of data of the same type. You know, another way to think of it, you can think of it instead of a data structure, you can think of it as a list. You can think of it like that. You can think of it as a collection as well. I sometimes think of it like a shopping list. Like when you go to the store, you make a shopping list. Always make a shopping list, by the way. You never want to show up at the store without a shopping list, especially if you're hungry. Then you're just going to buy everything that sounds tasty, and then everything will go to... anyway, always make a shopping list. So anyways, an array is a list or a collection of data that contains a sequence of data of the same type. That's important. And when we say type, we're talking about, you know, integers or doubles or strings, booleans. Those are all different types. And like was said in the video, it could be a type that you created. So for example, some of you created a runner class for yesterday's project. You could make an array of runners. Some of you created an array of, or a video game character. You can make an array of video game characters, stuff like that. One last thing that I unfortunately did not put on here, arrays are fixed size. Basically meaning once you say an array is going to hold 10 elements, that array will always hold 10 elements. You can't make it bigger, you can't make it smaller, it's always going to have 10 things in it. There. So here's an example. We may want to store a class's test scores by creating an array named scores. Instead of doing scores, score 1, score 2, score 3, score 4, all the way to score 29 for this class, I might just want to make an array of scores because they're all the same type. It's all just a list of associated data, so it makes sense for me to make an array called scores. And so let's say one student got a 75, another one got a 92, another one got an 88, all the way to the end of the class, a 94 and a 90. Well, these would be the contents, the stuff that goes in the lockers, to use the analogy they talked about in the beginning there. And they each have their own individual index, essentially where they're located, or their locker number, or you could think of it as an address as well, just like they do with strings. So the very first element is located at index 0. Maybe you want to make a note that this is always the index of the first element or the first thing in an array. It's always at index 0. And then 92 is at index 1, even though it comes second. 88 is at index 2, even though it comes third. And then all the way to number 28. Now, if the last element is at index 28, how many elements were actually in the array total? 29. So this indicates 29 total elements. Why? Because we started counting at 0 instead of 1. So one thing you could, do you guys not have my screen? You guys, who does not? You lost it. Okay, that's an interesting development there. Ethan, how's Agario going? Dingman? We're good? Do we need to shut off the computers or? Okay. We can. You can look at the class policies. Anything unrelated, I can take away your computer use for the day. And now you're on the video with me roasting you. I don't want that to happen either. I'm going to close Vayon because I saw some stuff I didn't like, and it was also crashing. That's what you guys do, right? When you see something you don't like, you just look away. Avoidance. Avoidance. Good coping strategy. No, it's not. Avoidance is not a good coping strategy. All right, let's try this again here. Window demo. Cordelia, I saw you lost yours, and who lost it? Lang. What is going on with Vayon today? Let's just try this. You got it. All right, let's see here. Got it. Ender, you don't have it. Okay, I've got this. Rico, you don't have it. I got you. You got it now. Evan, got it. Cordelia, got it. Kelman, got it. McNaughton, got it. Miller, got it. Safransky, see you. Grace, I got you. Abby, I got you. Garrison, guess what? I got you. Zeke, let me hit you with that window. Alec, guess what? Here's that window. Gavin, let me hit you with that window. Josh, enjoy. Anybody I missed? Oh my gosh, what? It says you guys... Okay, ducky. It says you guys had it. Okay, let's see. Where are your computers? Why don't I see your computers? They're like not there. Look at this. My computers got deselected? What's happening? I blame the sub that came and filled in for me yesterday. Don't tell him I said that. Oh yeah, did I tell you guys I left yesterday? Yeah. You good now? We're all good. Anybody else still missing? Garrick, Blade. Oh, he's got. Thank you. Confirmed. Okay, we're back, baby. That would have been a good time to play some Agario. All right. So back to this here. So they're fixed size. They all contain stuff of the same type. 0 is always the first element. And then the index of the last element is always 1 less than the length. So maybe I want to say something like index of last element is 1 less than length. So, for example, if the thing holds 29 elements, the index of the last one is 28. If the thing holds 100 elements, the index of the last one is 99. If it holds a million elements, the index of the last one is 999,999. The index of the last element is always 1 less than the length because we start counting at 0. All right. So, when you are accessing an individual element, it kind of looks like this down here. Scores, square bracket. Where can you find the square bracket? It's right next to the backslash on your keyboard. It's a grouping symbol. So, when you say the scores here, this is the name of the array. This sub with a number over here, I always say sub, so this would be said scores sub 1 if you want to know the English pronunciation of what you see, scores sub 1. That's how you talk about an individual element. This is the index number. 1 would be the index number here. And when you combine all that all together into something that looks like this, this is how you access an element. An element or a thing of the array. So all together you have to say the name of the array, square brackets, followed by an index number to access an individual element. So if I've got all those scores up there and I want to get score 94, I have to say scores, the name of the array, and then square bracket 27, the index, which I would name scores sub 27. Scores sub 27 is 94. scores sub 28 is 90. It's like if you're looking at your shopping list, if you want to see the second thing on your list, you would say list sub 1 or something like that. So you can access individual elements from your array. They're just the things in the array. And so I guess just to generalize, you always do name of array followed by the index. That is how you access an individual element of an array. Basically a thing in the array, a storage location, some of the data in the array. You can't just say scores, because that's the whole list of data. You can access an individual one, though, by saying scores sub followed by an index. So to tell the elements apart, we use indices. I think I've already mentioned that, just like we do with strings. Here's some examples down below. If I want to set the 0th element to 75, I can say scores sub 0 equals 75. It's almost like a regular variable, except it's got a name and a index there. And just lastly, the indices for an array start at 0 and end at, yeah, length minus 1. Very good. You guys are bright. Got it. Okay. Now that we've got that down, are there questions so far? Okay. There's a question here that says, can you think of another example of something that is like an array, like a row of lockers or like all the scores? I'm going to give you, let's say, 60 seconds to think about it. You can talk it over with the person next to you. Type it in the box there, and then I've got a place to write these down here, and we'll maybe get a collection here. So think about other things that might be stored in a collection, in an array, a group of data. I'll give you 60 seconds to think about it. And you can type it in there when you got an idea. All right. I've got some room for array ideas over here. Anybody feeling brave, or am I calling on random people? Yes, Grace. Houses on a street, beautiful. On a street, I think you could even go further if you wanted to. You could say a subdivision, in a subdivision as well. Or sometimes, I don't know if your parents ever talked, maybe you live in a condo, you have a homeowners association. Could be something like that. Yeah, Ryan, you got an idea. Rooms in a hotel, beautiful. Rooms in a hotel. Cordelia, you got something. Mall, yeah, mall with stores. Mall, I'm going to say stores in mall. Let me do that. Stores with, stores in a mall, excuse me. That's how that works. I haven't been to the mall in a minute. Let's go to the mall. Yes, Ethan. Car names, like in a dealer, or just like all the cars that a dealer makes, or all the cars at a dealership. You could probably go in either direction. Make and model. So cars, like I'm gonna put cars at a dealership, because that could be all kinds of stuff. It could be like what's the dealership right over here? Is that what is it? Ford something? I have no idea. Something. Okay, so they could have all of the it could either be all the cars in the dealership, or Ford could just have an array of all the different models that they make, or something like that too. That's a great one. Yes, Cody. Computers in a classroom, and my list kind of failed at the beginning. You guys all just saw, look at this. I kind of have an array. Cody, that was a great connection. Look at this on the side here. Some of my computers were not added to my list, so I had an issue there. Computers in a classroom. That's a great example. Anything else? You could think of other stuff. You could think of family members, people in a family. It could be your close family. It could be your extended family. You got one? Sodas in a machine. I like it. Cookies at the edge. Do they still call those cookies, or are they just dough balls that are heated in the microwave for 20 seconds? Or TV. So basically anything that you can think of a list of, right? Anything that you can think of a list or a collection of could be stored in an array there. So, all right. Let's keep reading together here. It says 6.1.1, declaring and creating an array. When we declare a variable, we specify its type and then the variable name. You guys know this. We've been creating variables for a long time. To make a variable into an array, the only extra thing you have to do is add square brackets in front of it. This would say instead of just a single integer, it's a list of integers or an array of integers named scores. So we put square brackets after the data type. This data type will be for all elements in the array. So similarly, you could do stuff like, let's look at some of your examples here. Maybe int square brackets room numbers. You could do something like that if you're at the hotel. You could do string array models if it's at the car dealership or whatever. You could do string square bracket stores at mall. Something like that. Now I will say, you'll see all of my variable names here for arrays are pluralized. That just kind of makes sense because we're not looking at a single value, we're looking at multiple values there. So it's very common when you're naming your arrays to use some pluralized name there. Does that kind of make sense? Okay, so it's basically the exact same way we usually declare variables, except we're adding square brackets. Those are square brackets, even though it looks like a weird boxy zero. And again, the square brackets are to the left of the backslash key. Usually when I'm typing, I have to add square brackets. I take my right hand off and I do index finger left bracket, index finger right bracket. Where have we seen that before? Yeah. String args. So we have kind of seen this notation before, we just didn't know what it meant. So this is how you declare an array. It says the declarations do not create the array. Arrays are objects in Java, so any variable that declares an array holds a reference to that object. If the array hasn't been created yet, and you try to print the value of its variable, it'll print null, meaning it doesn't have reference any object yet. So if all you do is this, I'm going to say this alone does nothing. All it really does is it names and says what it's going to hold. But if you actually want to add stuff to your array, there's an extra step you have to do. To actually create an array after declaring the variable, use the new keyword. Where have we seen that before? Like all of last unit when we were making objects, right? New runner, new video game character, new battleship, whatever you had, hull. To actually create an array after declaring the variable, use the new keyword with the type and size of the array, the number of elements it can hold. This will actually create the array in memory. You can do the declaration and the creation all in one step. See the string array names below. The string of an array is set at the time of creation, cannot be changed after that. So here's one example of separating it. If we go ahead and declare it here on one line, this will make an integer array called high scores. And then this will go ahead and instantiate it so that it's going to hold 5 integers. Whoa. Haunted screen, sorry about that. Or you can do it all in one line, which probably makes more sense for the most part. You say what it's going to hold, what type it's going to hold, and its name, followed by new, and then how many things it's going to hold. Go ahead and answer this question down below. All right, let's see why some of these are not so good here. Well, it says 10 doubles. This one holds integers, so this one's out. Let's see. This one will only declare it. It never instantiated it. I couldn't hold elements in there, so that one's out. It doesn't really create it. This one, the stuff is goofy in the square brackets. That one's out, so I believe the answer is B. Is that a true story? All right. It's good to be right, especially when you're teaching, I guess. Let's write this down on our note sheet here. I think I have a section. It says creating an array. Here's the first one we just talked about. If you know the size and the type. I said, but not the contents. You might know the contents. But if you know the size and the type, here's in general how you can create an array. This will create an array named A that holds 400 integers from 0 to 399 for their index. I wanted to go ahead and generalize this. In general, you would do something like type, followed by square brackets, then array name, then equals new type, square brackets, and the number of elements. So in that example, the type is ints, the name of the array is A, and it holds 400 integer elements. And then you can go ahead and fill them in later. We will learn how to use a for loop to go through arrays as well. That kind of makes them a little bit more powerful and faster to use. But you could go ahead and fill them in individually, one by one. At that point, though, you're like, why don't I just use a regular old variable instead? We'll talk about it. But in general, you can create an array like this. In the computer's memory, what happens is there will be 400 spots for you to put your integers in. There's a coding exercise down here. It says, in the following code, add another array declaration that creates an array of 5 doubles called prices, and another array of 5 strings called names, and the corresponding system.out.println commands. So let's see here. What do we have so far? Oh, interesting. Okay, so they're using the length. Let's go ahead and try this one together here. It says add an array of 5 double. You guys are in the same spot as I am, right? Add an array of 5 doubles called prices. All right, the first thing I do is the type. What's the type this array is going to hold? Double. Then, since it's going to be an array, I'm going to put left bracket, right bracket. And they have to be brackets. You can't go goofy with your grouping symbols like you can in math sometimes. It's got to be square brackets. Then I give it a name. Here they told me to call it prices. So I'll say prices. Then we put an equal sign, and we write new. Did I miss new on the notes? Oh, no. Okay, good. All right, new. And then whatever type it's going to hold. In this case, it's holding doubles. And it says it's going to hold 5 of them. So I put a square bracket there with 5. Questions on that one? All right, it says add an array of 5 strings called names. Okay, string is the type, square brackets, because it's an array. This says string array, then give it a name. Well, this one's called names, and it's supposed to hold 5 strings, so I say new string 5. Now, at that point, you should be able to run the code. I don't think it'll tell you anything about your array, though. We're supposed to add a line that looks similar to the one they wrote. They have a print statement that says array high scores declared with size. Oh, and this is interesting. We haven't even learned about this yet, and we're already throwing it in there. If you say the name of the array dot length, it'll tell you the number of elements that are in the array. It's a number. So let's go ahead and do the same thing for our other 2 arrays. I know the formatting's a little wonky on here. That's okay. I've seen some of your code. It's not new, right? Okay. All right. Just kidding. Just kidding. Oh, just kidding. Array prices declared with size, I'll say prices.length. Let's check that line there. High scores has size 10. Prices declared with size 5. And then we can do the same thing with names. Array names declared with size names.length. Now, if you're wondering what's the point of finding the size, I know the size. Well, okay, yes. But when you're writing your program, you know, maybe for one class there's 29 students, for one class there's 31, for one class there's 30 students. If you just hard code in the number 29 or 30 or 31, it's going to change for every class. So it's much better to be able to programmatically find how many elements are in an array. Now some of you are looking at this and you go, oh, I remember finding length of strings. Yeah, we did do dot length for strings, but it had parentheses after it and it doesn't here. Why? I wish I had a good reason for you. I just don't. But I do have some good news. Why don't we take our 2-minute break, stretch our legs, get a drink of water, and then we'll come back and crush the rest of this lesson here. Give me one. Zoom. Okay. All right. Before we get back into the lesson here, let's just do like let's say I want to make maybe I want to make an array of strings. So maybe I want to make an array of friends. Let's here's what we'll do. Let's do an example. Make an array to hold the name of your best friend in each hour. Now, I know some of you are saying, Mr. Foster, what's the limit on how big an array can be? Everybody's my friend. Or some of you might be saying, Mr. Foster, what's the point of making an array of size 0? I understand both of those standpoints, but we're just going to pretend that you have a best friend in each hour, even if it's me, which is okay. It's like saying your best friend is your mom, which is fine. Which is fine. I'm like your code mother. All right. So if I wanted to do this, make an array to hold the name of your best friend in each hour, I would probably make an array of strings. I would say string followed by square brackets. Then I'd have to give it a name. Friends, I think, is a great name. And then I have to say equals new. Am I going to be able to squeeze this in? New string. And then since there's 5 hours in the day, I'm going to hold 5 friends in my array. So that would go ahead and make an array somewhere in the computer's memory and make an array that's going to hold 5 strings somewhere. Basically, the computer will automatically allocate all that room. So what it kind of would look like is friends would point to some location in memory that would have, let's see if I can do this right, 1, 2, 3, 4, 5 spots in it, and they would be indexed as such, 0, 1, 2, 3, 4. And right now it's blank. We haven't filled in any of the friends, but we've just said go ahead and allocate room for 5 of my friends. Make a little bit of room in the computer's memory to make room for 5 of my friends there. And I don't know, you could fill in like Rachel, Phoebe, Monica, Joey, Chandler, Zeke, whatever. Okay, so that's one way to go ahead and create and allocate the room in the computer's memory space so you can do that. Questions on creating an array in that way? Right now we're just talking about how to create an array. That's all we're doing. So how do we make it? Okay. There's another way to create an array. Let's say you know exactly what you want to go in the array. We use what's called an initializer list. Another way to create an array is to use an initializer list. You can initialize or set the values in the array to a list of values in curly brackets. I call these curly braces. Hit me. Can I say? I'm not logged in, so I can't say it. Okay. When you create it, like below, in this case, you don't specify the size of the array. It will be determined automatically from the number of values that you specify. So here's one example. Let's say we have an array called high scores. If I know what the arrays are, if I know what the values that are to go in the array are right at the time of creation, I go ahead and declare it like usual. I put an equal sign, and then in curly braces, I put the exact values in there. Same thing with names. I could do something like string names, and then I can put the values directly into the array like that. Now this is often missed. People forget the quotation marks around string values for some reason. Never forget that if you want a literal value to go in, you have to put quotation marks around it for strings. So the left side looks very similar to what we've been doing so far. The only difference is now on the right side, we don't say new, we don't say the type, we don't say the number of elements. We just say, here's all the stuff. And you just put it in there. And then the Java will figure out the size. Java will go, okay, 1, 2, 3, 4, 5. I need to allocate room for 5 elements. Java will go, okay, 1, 2, 3, 4, 5. I need to allocate room for 5 elements. You don't need to say the size because Java is just going to count itself. It says when you create an array of primitive type with initial value specified, spaces allocate. When it says primitive type, like it just means int, boolean, double, anything that starts with lowercase letters. With initial value specified, space is allocated for the specified number of items of that type, and the values in the array are set to the specified values. When you create an array of an object type, like string or anything else that starts with a capital letter, like what you guys made yesterday, with initial values, space is set aside for that number of object references. The objects are created and the object references set so that the objects can be found. So I just wanted to demonstrate this for you really quick here. I'm just going to show you something in the interactions pane. You don't have to do it. I just wanted you to kind of watch real quick. Let's say I make an array of integers called lucky numbers. Anybody have a lucky number? 5, 2, 8, 62. One more? 1. Okay. So when I do that, here's what it looks like in the computer's memory. No. Why are you doing that? Stop. Get out. Here's what it looks like in the computer's memory, if I can show you. This is what's happening in the computer's memory. It stores at index 0, 5, at index 1, 2, at index 2, 8, at index 3, 62, at index 4, 1. If I do the same thing with like a string, it's a little bit different. What could we make an array of strings of? What? Dog names. Okay. Who had a dog? Was that your dog, Ryan? That we talked about the other day?
Yeah.
What your dog was? Bernard. Okay. You got Bernard. Let me capitalize them properly. I've got Bella. Other dogs? Dora. Dakota. What else? What's yours, Cordelia? Tess. And what were you saying, Kaylin? Oh, your cat's not. Oh, sorry. Cats don't count. Nellie? Nilly. Millie. Millie? Millie. Okay. There we go. So if your dog didn't make the list, it's okay. I also think it's okay. Now, notice how this looks different. Let me pull up the lucky number one as well. Here's the integer. The primitive one is over on the left. It just stores the value right in its spot. The one with strings is a little bit different. Why is the one with strings a little bit different? Well, objects are stored in memory just a little bit differently. So what you see here is essentially the 0th element points to a location that contains Bernard. That's how objects work. With primitives, like ints, doubles, booleans, it just stores the value directly. With non-primitives, like strings or any other object you create, your runner class, your person class, student, video game character, whatever, ball class, it's going to store an address for where it is. So that's why it's pointing somewhere instead of having the value directly inside of the box. So it is a little bit different there. Questions there? Okay, so those are initializer lists. Arrays know their length, how many elements they can store. It is a public read-only instance variable, so you can use dot notation to access the instance variable. Array name dot length. Dot notation is using variable name followed by a dot and then the instance variable name or a method name. Before we do this activity down here, I do have this initializer list written down, but we should say that it's called an initializer list. So this here is an initializer list. I've got an example there where you're storing the elements directly into array A. In general, you again do the type, followed by square brackets, followed by the array name, and then you put equals, and then you put your values into the array with a curly brace. Dot, dot, dot. I hope you guys are becoming curly brace artisans like I clearly am. Look at that left curly brace. Anybody want to say anything about that? Get out. Just kidding. Just kidding. Just kidding. It's okay. You know art when you see it. That's all I'll say. That's all I'm going to say there. So you say the type, square brackets, the array name. Now, again, why would you create it this way over the other way? It's just two different ways to create an array. The one up top is say, just go ahead and allocate this much room, and I'm going to maybe fill it in later. The one down here says, I know exactly what I want to go in my array. I'm going to fill it in right now. And so if you were doing the friends array example that we had earlier, you could go ahead and do something like, oh, here, let's just hit me with a friend. String, square brackets, friends. And then, in your curly braces, you could put your friends in there. Whoever your friends are. Bob, Mom, whatever. So that's an example of creating an array using an initializer list. So two different ways to create an array. The first one we saw up above is when you say, just go ahead and allocate this much space. I'm going to maybe fill it in later. The second one is, hey, I know exactly what I want to go in the array right now. Please fill it up for me. I don't need to state the length because you're a computer and you can do the counting yourself. It's in your name, compute-er. Okay. And then it talks a little bit about the length there, which is nice. You can just say the name of the array.length. Maybe I'll put that in at the bottom. Name. Nope. Array name. Dot length. No parentheses. Gives number of elements in the array. Now, what could you do with that? All kinds of stuff. You could look at two lists and see if one list is bigger than another list. You could say if period 1 dot length is greater than period 2 dot length. Well, then period 1 has more students. You could write a for loop that loops through an array, and you could relate it to the length of your array, something like that. If you have one array that represents a length and another one that represents a width, you could do length dot length times width dot length, and you could figure out the area of those two arrays together. You can do a lot of different things with the length of an array, but it is available to you if you want to use it, essentially. Okay, what's our activity here? It says try running the code below to see the length. Try adding another value to the high scores initializer list and run again to see the length value change. Okay, well right now it's got 1, 2, 3, 4, 5 values. If I don't know why 68 is part of the high scores list here. That's a little scary. Maybe we'll add in something that's higher than 68 to build people's self-esteem. And then when I go ahead and run it again, I see it's gone up to 6. Java is automatically figuring out the number of elements that are going to go in the array based on the number of elements I put in that list. So just another way to create an array. Number 1 is when you just say how many spaces you want. Number 2 is when you say what's actually going to go in this initializer list there. Questions? How are we doing? Okay. It says, note that length is an instance variable, not a method, unlike the string length method, so you don't add parentheses after length. However, if you use parentheses after length during the exam, okay, you won't lose any points. Good for you. All right. It says, which index is for the last element of an array called high scores? We said up above that the index of the last element is going to be the length minus 1. Is it B? B, because the index of the last element is always going to be the length minus 1. If it has 30 things, the index of the last one is going to be 29. 30 minus 1. If it has 100 things, the index of the last element will be 99. 100 minus 1. So on, and so on, and so on, and so on. Okay. That's actually all the material we're going to learn today. On the back is stuff we're going to look at tomorrow. But we do have a little, I'm hoping, easy assignment today. Has anybody ever used Edpuzzle before? Oh, don't hit me. Don't even hit me with the whining. Don't hit me with the whining. What I have is our good friend Daniel Schiffman, who is like the head of the Processing Foundation and writes a lot of the code for processing and has a really engaging YouTube channel where he discusses Java concepts and stuff like that in processing. I've got 2 videos. One of them is 5 minutes and 32 seconds. The other one is 8 minutes and 37 seconds. I know. Where will you find the time? I'm going to go ahead and hit the assign. That's you guys. Let's see. When should we make this due? Next Thursday. I was thinking of what time tonight should I make it due. 11:59. Beautiful. And start date? Can I? Okay. Start date today at 12 a.m. That's midnight. Okay. I understand now. I understand how times work. But why is it not? Save! There you go. Get out of here. Okay. Prevent skipping, you bet. You guys want closed captions? Post on the classroom. Assign to class. Look at that. They should be on the classroom now. Let's see if that's a true story. How does it work? That's a great question, Trevor. There's 2 videos, varying in length, about 15 minutes total. It checks 2 things. It checks that you watch them. I've also inserted questions in the videos. So, and I've also prevented skipping. So what happens is it plays the video, and then I've inserted a question in there, and it gives me a report on who watched all the videos and what your results were on the questions. Now, am I going to grade it for correctness? No, but I'll be kind of curious about people that are getting everything wrong. Maybe. And you can't just click play in the background because it stops when there's a question. Now, we do have about 10 minutes left here, I believe. So you could, if you wanted to plug in your headphones or something like that to the back of the computer, or you wanted to watch it with closed captions on, if you wanted to do that. I think there's also an Edpuzzle app for your mobile devices. You could do that. But essentially, your homework tonight is to watch those 2 videos and answer the 10 total questions so I get some data on where we're at tomorrow. That is it. Questions? You should be able to access it directly from Edpuzzle. I see some people already have. That's wonderful. I will stop the recording and let you guys have it.